everyone, in this video we'll be solving the following problem. If we take all the face cards from a standard deck and deal them into 4 3-card hands, what is the probability of each hand having 1 king, 1 queen, and 1 jack of any suit? So have a think about it and I'll be right back with the answer. Okay, so we can solve this problem by splitting up the game into the 4 hands that we deal. And so in the first hand that we deal, we can think we know that there's 12 cards, and we can think about how many ways there are to choose 1 king, 1 queen, and 1 jack from those 12 cards. And you can think about, since the order doesn't really matter, we have 4 possibilities to get a king, since there are 4 kings, 4 possibilities to get a queen, since there are 4 queens, and then 4 possibilities to get a jack. So there's actually 64 ways to get a king, a queen, and a jack. And how many total ways are there to get 3 cards from those, or a hand of 3 from those 12 cards? Well, it's 12 choose 3. And this is 12 factorial divided by 3 factorial times 9 factorial. And so if you think about it, this is 12 times 11 times 10 all the way up to times 1 over 3 factorial times 9 times 8 times 7 all the way up to 1. And so if this was a 9 here, all these get canceled out by this. And so this is just 12 times 11 times 10 divided by, well, 3 times 2 times 1. And so we can have some cancellation here as well. You can cancel this with the 10 and this gives 5. And then this with the 12, which gives 4. So the answer is 4 times 5, which is 20, times 11, which is 220. 220. Let me erase this. All right, 220. And so the total the probability of getting 1 king, 1 queen, and 1 jack from these 12 cards is 64 over 220. Okay, so to keep this cleaner, again, we have 4 times 4 times 4 ways, so 64 ways to get 1 king, 1 queen, 1 jack. And so the probability, the whole, there's 12 choose 3 ways of choosing 3 cards from 12. And so the probability is 64 over 220. Okay, let's move on to the second hand. For the second hand, since we already picked 3 cards from those 12 cards, we only have 9 cards left. And since there's 1 king, 1 queen, and 1 jack on, again, we're assuming that the first hand did have a king, a queen, and a jack. And so actually, at the end, we'll just multiply these probabilities together since they're all conditioned on the previous probability. But yeah, anyway, since there's 9 cards left, there's only 3 kings, 3 queens, and 3 jacks left. So actually, the number of ways we can get 1 king, 1 queen, and 1 jack from these 9 cards is just 3 times 3 times 3, which is 27. Okay, and so that means the total number of ways to choose 3 cards from 9 cards is 9 choose 3. And again, we can do the same trick. So 9 choose 3 is 9 factorial divided by 3 factorial times 6 factorial. But again, like we can cancel out some of these terms. So this is just 9 times 8 times 7 divided by 3 times 2 times 1. And so here we can cross this out. This is just 3. Cross this out. This is 4. So the answer is 3 times 4, which is 12, times 7, which is 84. All right, and so here the probability is given by 27 over 84. Okay, but let's move on to the third hand now. For the third hand, we can have 6 cards since we already chose 6 cards from the deck. Here we can just replace this by 2 by 2 by 2, which is 8, since there's 2 kings, 2 queens, and 2 jacks left. The total number of ways are 6 choose 3, which again, we can apply the same trick, but this is just 20, so this is equal to 20. Actually, let me put this is equal to 84, and this is equal to 220. And then down here, so the probability is 8 over 20. Okay, and so for the fourth hand, actually, we only have 3 cards left. And remember, we're assuming that all these 3 cases are already true. So in this case, actually, we only have a king, a queen, and a jack left. So the probability down here, I mean, this is just 1 by 1 by 1, which is 1. And then this is, 3 choose 3, which is also 1. And so here, the probability is 1 over 1, which is 1. Which just means that if we get to this point, the last 3 cards will always be a king, a queen, and a jack. So the probability here is 1. Okay, and so as I said, the total probability is just going to be the multiple of these 3. So actually, we can simplify this to, we can divide by 4. This is 16 over 55. Here we can divide by 3, which is 9 over 28. And here we can divide by 4, which is 2 over 5. And so we just multiply these together, and then back here we have 1. And this is actually, it's not really easy to calculate by hand, but it's about like 0.0374, something like that. So the probability that if we pick these four hands, that each of them has a king, a queen, and a jack is this, 0.0374. Okay, I hope you enjoyed that problem. If you did, please consider subscribing, and I'll see you next time.